In this video, I will be showing you how to construct the 95% confidence interval for a sample mean. In the following example, I am using the Chapter 8.2 mean of 5.38, rounding it up to 5.4, and the standard error that was 0.18, rounded up to 0.2 for the point of this example. This example is to give you the idea, not the correct values. We'll get the exactly correct values from a spreadsheet. Our small sample size of just 5 marbles means that our distribution should be a t-distribution. The following example uses a normal distribution, and that's why the numbers below won't be exactly correct, but they'll give you the idea. In the Chapter 8, we had 72 marbles that had a known population mean of 5.2. That's the red line you see there. If I take samples from that population, I will wind up with 95% of the samples falling in between 4.8 and 5.6. So if I take hundreds of samples from that population, 95% of the means of those samples should be between 4.8 and 5.6. That's up and down a couple of standard errors. That's the part that won't be correct because our sample size is a little too small. But that's the basic idea. Now, the very first sample in Chapter 8 was a sample with a mean of 5.4. That had a sample standard error of 0.2 if rounded off to 1 decimal. And you can see that here. The purple is the 95% confidence interval for the sample with a mean of 5.4. The important thing to note is that the population mean is inside the 95% confidence interval for this sample. In other words, this sample says that if we calculate the 95% confidence interval for this sample, it runs from 5 to 5.8. And 5.2 is between 5 and 5.8. Notice also, more importantly, that the purple curve and the purple shaded area that you see are the same as the red curve and the red area, just slid to the right. It's symmetric. That means I can change my language to, instead of talking about 95% of the sample means landing within a certain range of the population mean, I can now say that the population mean should be found 95% of the time within the interval in purple from 5 to 5.8. In other words, 5 to 5.8 should capture a population mean for the marbles 95% of the time. That's a 95% confidence interval. You can see pieces of it right in the normal distribution probability there. We'll get the exact values from a spreadsheet, and I'll show you how to do that in just a moment here. So I'm going to put the example away and open up my spreadsheet. This spreadsheet has the marbles that sample from Chapter 8, with the different masses and the average of 5.38 there. And the first thing I'll do is calculate the sample size. And to do that, I'll use equals, and I'll do the count here. And let me check my, I still have it here. I saved that in my clipboard, so it'll be easier to type. And so there's my sample size n of 5. My sample mean equals the average. I'll do the same thing. I'll grab my clipboard value. Makes it easier to type. That's the range for that sample. And that's 5.38. We already know that. The sample standard deviation, STDEV. I'll use the same borrowing of just shortcuts that are good to know in an app. And this is a new part from Chapter 8. The standard error of the mean is the standard deviation divided by the square root of n. So equals the standard deviation, that's right there, divided by the square root of the sample size, n. Remember, that's back up here, n2. So that's 0.18. That was the number we rounded off to 0.2. Here's the new part in Chapter 9. T-critical will be how many standard errors we need to go to the left and right of the sample mean, up and down, to figure out what the 95% interval is for these capturing the population mean. There's a new number in here, alpha. Alpha is the area in the tails. Let's go back to our graph and I'll show you what that area is. Way back here, let me turn off the red one for a minute. Turn off this red normal distribution. Come back up. I'm moving some sliders, but this guy should be 5.4 there, that positive. Yep. The area in green is the tail area. That is, we've got, if I turn it off, that's the 95% confidence interval. Then those green tails on the left and the right, that's the area in the tail. Since the 95% confidence interval is 95% of the area in the tails is 5%, or in decimal form, 0.05. That's what we'll be using back here. And so to calculate this, I'll be typing in the t-critical function, which is TINV. It's T inverse, open parenthesis. Now I'll be using the 0.05, the area in the tails, and then I'll be using n minus 1, n as in sample size, minus 1. I missed on that one, so I'll get back and fix that. N minus 1. That's the formula for t-critical. That's new to Chapter 9. 0.05 is a standard alpha that we use. I'll talk more about alpha and what it means in Chapter 10. But it will be our risk of what's called a type 1 false positive error. That number is always 0.05 in this class. That's a standard value that most fields use. Education, social science, and many other fields use 0.05 for alpha. You will learn about other alphas later. And if I press enter, you'll see it's 2.7764, about 2.78. So I have to go down 2.7 standard errors and up 2.7 errors from the sample mean to calculate the 95% confidence interval. So let's do that. I'm going to go down. I'm going to start with the mean, and I'm going to go down, minus the t-critical. In other words, I'm just tapping on those, times the standard error. That's how many standard errors I have to go down. Press enter. 4.87 is the new bottom of my confidence interval, below the old value of 5. Then I'm going to calculate the upper bound for the 95% confidence interval. I start with the mean, and now I go up, plus the standard errors again, times the t-critical. The order doesn't matter since it's alpha, since this is math. N5 times N6 is the same as N6 times N5. It's commutative. By the way, this product of the standard error and t-critical is sometimes called the margin of error in some books. But I've tended to avoid adding more language. So my confidence interval runs from 4.87 to 5.9. Think of it like a number line. 4.87 is the bottom, and 5.89 is the top of the confidence interval. I expect the population mean should be between 4.87 and 5.89 95% of the time. That is, indeed, in this case, we are correct, I should say, because it was 5.2. So we got the right answer. If somebody told me, well, the actual population mean is 4, I'd say, well, then this sample doesn't come from that population. It's not in my confidence interval. 4 is below the bottom, off the bottom. So that's all there's to calculating these. The new pieces are this piece here, the t-critical value, the lower bound, the upper bound, and we'll talk more about in Chapter 10.1 how we use those. Thanks for watching.